Now we're going to work on Chapter 5, Section 1. And once again, we're going to feature these Math Zone booklets that we have, where we have additional exercises in Chapters 1 through 5. So what I'll do is sort of very lightly review the concepts involved in exercises 5.1. The first one we have is the degree of a term. Well, the degree of a term is based on, first of all, just the exponents that are associated with variables. So we don't look at the numbers or any exponents that are on the numbers, just the exponents that are on the variable. So here we see this is x to the second. So the degree of this term would be 2. Now in this particular term, you have to note that each of these variables have an unwritten exponent of 1. And when we figure the degree of a term, it's the sum of the exponents on the variables. So here, 1, 2, 3, the degree of this term is 3. Now in this term, again, we're only looking at the variables, but we add them up. 2 plus 3 is 5, plus 4 is 9. So the degree of this term is 9. And all of these are, since they're just single terms, are classified as monomials. We use the prefix mono, indicating one term. Now as we move on, we are wondering about the degree of a polynomial in which there are more than one term. If there are only 2 terms, the prefix for that would be a bi. Let's put it the right way here. Binomial. This has 3 terms, so this is a trinomial. And beyond that, they're just called polynomials. So the way it works is, in a polynomial, we want the highest degree of any single term. So what we have to do here is figure out what's the degree of each term, and then we just pick out the highest one. So here, 4, 2, 6, z has a 1, so the degree of this term is 7. Here this is 8 plus 6. This will be 14. And this is, keep in mind there's a 1 there, 6. So the degree of this polynomial would be the largest degree of any single term, and it would be 14. Students often make the error of adding them all up. No, it's just the largest degree of any single term. Next, I'd like to go into what are called like terms, because this is a big part of Chapter 5, and we use this in other chapters already, but as a review. What is a like term? Well, in a like term, we don't care what the numerical coefficient is. We only care about the variable part. So if the variable part is the same, that is, it has the same letters and the same exponents, they are like terms. Now if the order is different, here we see xy yx, that's still considered a like term. Now here, again, these are like terms because the variable part is exactly the same. And again, if the letters were switched, that would be fine. So the exponents are the same, the letters are the same. So these constitute what are called like terms. Now in example 5, what they're asking you to do is you have a binomial that's in a parenthesis, a binomial that is in a parenthesis, and then there's a sign of plus between the two parentheses. So what they're asking you to do here is to add. Now, one technique, again, there's a couple of ways to do this, but I'm going to show you a way that's almost foolproof. And that is to rearrange something that is horizontal into something that is vertical. So you take away the parentheses, that's no problem. As long as there's a plus, you just take away the parenthesis. And I'm going to write this here, 6y squared. Now I look in the other part, is there another like term? Well, right here. So I put these two like terms underneath each other. Then I have a negative 11 and a negative 5. So what I'm going to do now is add up my like term columns. So this becomes a negative 16, and these are just 2 plus, so plus 12y squared. And we don't write the plus. In this one, again, you have a trinomial now that you are adding to another trinomial. Now, again, you may have another technique for doing this. What I'm showing you is a way that's almost foolproof. So this is your term. You now look through your other term or series of terms. Do you have a like term there? Well, this one's a like term. Now remember, there's no numerical coefficient that's showing, but there is a 1 there. And if you want to put a 1 there, that's okay. And there's another like term. I'm going to leave a space here. I'll put the 7 out there because here I'm going to put this because there's no like term in this trinomial that will pair with the 7, nor is there one here. So I separated it like that. Now that you have your like terms in a column, I call that like term columns. It's just a matter of adding them up. And you might say, well, is this addition or subtraction? Well, it depends how you look at it. But let's think of it now as subtraction. Or adding unlike sign numbers. Now you could do it horizontally, and that may be the way you do it. But again, this is a foolproof method. It's going to be particularly useful when we do subtraction, which is next. Again, this is a trinomial in a parenthesis. Another trinomial in a parenthesis. But this time, we see the sign is subtraction. Now, the general rule for subtraction in algebra is to change the signs and add. Another way of thinking of this is you could put a 1 in front of that parenthesis, and as you clear the parenthesis through distribution, as you distribute that negative 1 through each of these terms, the signs are going to change. So we can change this to plus, make this a negative, make this a plus, make this a plus. And now we just remove our parentheses, and again, I suggest put them in like term columns. So originally it was subtraction. What we did is changed all the signs, and now we're going to add. They are in like term columns. And there is your answer. What students often do is an error. They'll change the first sign, but then they don't change the other two. So again, you want to have a model of what to do, a strategy. Change this to a positive, or just multiply through by a negative, change all the signs, and then treat it as an addition problem. In some cases of unlike sign numbers.